Okay guys, so notes for 4.1. The front side is just kind of giving you some examples as we move forward. So all this means is that if you take the square root of two things that are being multiplied, you can separate them out and then try to factor them. So you're trying to find perfect squares. So 12 is basically 4 times 3. So they separated them out, and then the square root of 4 is a 2. So that's how they got 2 times the square root of 3. It works the same thing with division. If you have the whole fraction under a division sign, you can separate it out, just like they did here. The square root of 9 is 3. That's how they got it on the bottom. The bottom part is a part that people forget all the time. And it talks about rationalizing the denominator. And all you need to know is that if you have this on the bottom, anything under a square root, you're going to multiply by that number, top and bottom. Because what happens is square root of 7 times the square root of 7 is the square root of 49, which is 7 all by itself. And then you multiply the two top numbers. So that is all that this front side is doing. Okay, and then so they want you to solve, and they want you to solve for x. So what they do is they take the equation, then they move this, they add the 16 to both sides to get here. Then they divided both sides by 2 to get here. Then they took the square root of both. So the square root and the squared, it undoes it. That's how we get the x by itself. And we know it's either a positive or a negative number here, because the square root could have been a positive inside or outside. Then they split it up. 4 times 2 gets me 8, so that's how they split it up. And then the perfect square of 4 turns into a 2. So it's plus or minus 2 square root of 2. So the next one, we're going to solve for b. So again, we have negative 5x squared plus 9 equals 0. So we're going to subtract 9 from both sides. And we end up with negative 9 over here. We're going to divide both sides by negative 5. And we get a positive 9 fifths. Okay? So we end up with a 9 fifths, which is the same thing as square root of 9 over the square root of 5. Okay? So we put that here, square root of 9 over the square root of 5. We're going to simplify the numerator. The square root of 9 is basically a 3 over the square root of 5. And we have to rationalize the denominator, which means we have to multiply this by that bottom square root all over itself. So we end up with 3 square root of 5 on top, and the square root of 5 times the square root of 5 is a 5 by itself. So our x is a positive or negative 3 square root of 5 over 5. So on your own, or just more practice, we get x squared equals 24, the square root and square root. So we get x equals plus or minus the square root of 24. So we need to factor out 24. So 24 is like saying 8 times 3. 8 is like saying 4 times 2. Okay? So, and then this is 2 by 2. This is how I factor. So I can bring a pair out. That's going to end up being a 2 on the outside. Those 2 end up staying in. So that's like a 2 times a 3, which is saying 2 square root of 6. So my answer to number 3, x equals positive or negative 2 square root of 6. Because I factored out square root of 24, ended up with a 2 on the outside and a 2 times 3 on the inside. Same process again. I'm going to move the number. Negative 4x squared equals negative 13. Divide everything by negative 4, and I get x squared equals a positive 13 over 4. Square root and square root. So I end up with x equals plus or minus the square root of 13 over the square root of 4. Okay, that 4 simplifies. Ooh, you can't see that. The 4 simplifies to a 2. The 13 won't simplify at all. So we end up with a square root of 13 over a positive 2, plus or minus. And that is how we do number 4.